Evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. This is going to be a very interesting lesson, as you can see on the monitor here. So you'll notice that most of the times I'll be looking this side because this is where I have my second monitor. And yeah, so as we dive into this lesson, subscribe to the channel, leave a like, share the video, and invite someone to come and subscribe to the channel so that they get the same knowledge that you are getting. All right, so I think we can dive into the lesson. All right, now this is simple. All right, I'll be done. Maybe let me try maybe 5 minutes. All right, show that maybe less than 10 minutes. Show that CRI equation in polar form, du d theta equals to this, and that is equals to that. So we're going to do that in less than 10 minutes, right? So we know f of z in polar form is equal to r e to the I theta, all right? This is f of z in polar form. And we know that f of z needs to have a real part plus I an imaginary part, all right? U plus IV. So meaning that U plus IV is equal to R e to the I theta. And basically the goal here is just to differentiate everything with respect to R, then everything with respect to theta, and we are done. So step one, differentiating with respect to R. So differentiating everything with respect to R, we get U plus IV, even this side with respect to R, everything with respect to R. Okay, let me see. Okay, du dr, it just be du dr. Then we see that dr, this dv, it will be I dv dr. We see that. So plus I dv dr equals to, now differentiating this part with respect to r. So this part doesn't have any r in it, so our concentration is only this part. So this part with respect to r will just be 1, okay, meaning that here will remain with e to the I theta, and this is our equation 1. Okay, so that is our equation 1. Now equation 2, so this is how we're going to get equation 2. We differentiate everything with respect to theta. So we have u plus iv equals to r e to the I theta. Differentiating everything with respect to theta, we have u plus iv equals to the theta, the whatever is here, or the theta, r e to the I theta, like that. So now our derivative here will be so du d theta plus I dv d theta equal to, and on this part same applies. This r doesn't have any theta, so our concentration is e to the I theta. Now how do we differentiate e to the f of x? So e to the f of x, okay, you drop the power, you differentiate it, then everything to the f of x. So this is what we're going to do. So this would be I, because the derivative of this with respect to theta is just 1, so it will just be let me write this. So we drop this and differentiate it. Okay. Now differentiating I theta, theta is just one variable, so more like just x. So differentiating theta, it will just be, will just remain with I. Then we are going to have our r there and e to the I theta. All right. So this is our equation 2. Okay. Now we see that in our equation 1, in our equation 1, this is our equation 1. We see that we have e to the I theta here. We can replace this e to the I theta right here in equation 2. Are you seeing that? So we can replace e to the I theta. This e to the I theta can be replaced here. So meaning that we're going to replace this part here. All right. So replacing this, where e to the I theta is equals to this, and this part is e to the I theta. So we're going to do that. So replacing in equation 2, saying replacing equation 1 in 2, we're going to have, so this is this part of this equation. So we write equation 2, then here that's where we're replacing. So that is du d theta plus I dv d theta equal to I r, and what is our e to the I theta? It is this. So that is du dr plus I dv dr. Okay, so this is v with respect to r. So from here we just simplify and we're done. Under 10 minutes we're done. So let's just simplify this side. So we write this is the u d theta plus I dv d theta equal to, we multiply this times that, we're going to have I r du dr, and this I times I, it will be negative r, okay, dv dr. Then from here we just equate the real parts, the reals and the imaginaries. Equating the real part and the imaginary. So this is the real part. It is the same as this real part. So remember, so that is du the theta is equals to negative r du dr. And here this is the imaginary part. The v d theta will be equals to r du dr. So let me write in red pen. So that is dv d theta equals to r du dr. So those are the Cauchy-Riemann equations in polar form, and we've done them in 9 minutes. So without the talking, it can even be done in 5 minutes. All right. So these are the Cauchy-Riemann equations. Now let's look at an example where we're going to use these Cauchy-Riemann equations. All right, let's look at an example right here. Excuse me. So this is, I think it should be among the questions in the tutorial from Florida College of Education. So we are asked to determine if W equals to log Z is analytic. All right. Now we will use the polar form because we know that Z is, let me use a different pen for the solution. I'll use blue. We know that Z is equal to R e to the I theta, meaning that W will be equals to, where there is Z we can put R e to the I theta, like that. Okay, and mind you, this is log Z to base E. If it was to base 10, they just write, if it was written like this, then we would have known that this is to base 10. But if there is nothing there, that is to base E. That is a disclaimer that you should have. All right, so yeah, so that is to base E. If it is just LG with nothing down here, then you know that what you're dealing with is in base 10. All right, yeah, so if it is just LG, then Z, you're dealing with base 10. If it is just log, then you know that you're dealing with base E, like that. So this is base E. So we can, all right. Also, we know, all right, so away from the log. So we can write this as a log. We can even put a base E there, but there is no need, so but you should know that it's in base E. So among the log properties is that when we have a product inside a log, all right, we can separate the product by this uh, identity. So it will be log R plus log e to the I theta. Okay, and we know that this is in base E despite not showing us. So meaning that here we can drop the power according to logarithmic properties. We can drop the power. Okay, so we are going to have let me write here. So we're going to have W being equal to log base E of R plus I theta log E power E, and this is just 1. So this is the same thing as it will just be log E like that. Okay, so now this is basically 1, so it is cancelled, meaning that this is our real part and this is our imaginary part, meaning that our U will be equal to log of R to base E, okay, and our V will be equals to theta, right? And we want to show that this function is analytic. So remember our Cauchy equations. So right here we have our Cauchy equations. Du d theta is equals to negative dv dr. So we need to find this partial derivative. Do we have du d theta? Du d theta, do we have any theta here? So we know that du d theta is equal to 0. This is v. Alright, what was I copying? This is v. The v, the r. The v, the r. Do you have any r in v? So let me just. So this should be v. Then that's copying, and this should be u. Alright. Alright, so du d theta equals to 0. Do we have the v, the r? The v, do we have any r in v? So the v, the r is also equal to 0. So meaning that the first equation, where there is du here, where there is du d theta, we put 0 equal to negative r, where there is the v dr, we also put 0. So meaning that we're going to have 0 equal to negative r times 0. Okay, and we have 0 being equal to 0. The first part has been satisfied. Now we go to this other part of the equation. Okay, dv d theta. Dv d theta is just 1. Okay, let me just see. So dv d theta, v with respect to theta is just 1. Okay, then we also need to find du dr. Du dr. Okay, so we have u being equal to log to base e of r. So let's convert this into an exponent. We're going to have e to the power u is equal to r. So instead of finding the u dr, we're going to find the r du. Okay, the r du, because we can flip this. This can be written as r. This can be written as r equal to e to the power u. So r with respect to u, it will just be e to the power u. All right, and we know that we are looking for, okay, so meaning that our dr du is equal to, where there is u, we can replace with this, which is properly here, which is dr du will be equals to e. Where there is u, we can replace log to base e of r. Okay, and we know that log to base e is the same thing as natural log. All right, or let me say this part, there should be an identity. I don't know if there is even need for me to prove that identity, but you are aware of that identity. So this is a log to base e is just the same thing as the natural log, right? So this the r du is equals to e to the natural log of r, and the natural log, e to the power natural log of r is just equal to the r, meaning that our dr du is equals to r. Now we are looking for du dr, so du dr will just be the inverse of this, which is 1 over r. Okay, so that is what will be there. Okay, I think yeah, so that is what will be down there. So meaning that this is our r. Okay, this is our du dr, and this is our dv d theta. Now replacing in this equation, dv d theta is 1. Okay, so that is 1 equal to, there is this r here, r. Okay, then here we replace our du dr, which is 1 over r. So this and that will cancel, or will simplify this and that, so remain 1 is equals to 1. So since we had this and we have this, w equals to log z is analytic. So this is basically it. Have an awesome day.